Chapter 25 of sdm4 concerns itself with inferences for regression. In the same way that we've done inferences for 1 and 2 samples, proportions, and means, we can be thinking about inferences for regression, picking up from chapters 6 and 7. This example looks at the relationship between waist size and body fat, and introduces this idea of population and samples more formally for regression. It describes this idea that there's equal variance at each one of those, which we'll see in a few minutes. It now introduces these betas that I referred to earlier. So those are the same as what the authors would call B. Still hat when we have estimates of those things. The assumptions and conditions, we have linearity, we have independence, equal variance, and normal population assumption. I will typically call these the line assumptions, L-I-N-E. And if all those were true, we'd get some idealized thing like this. We can think about different ways of checking the assumptions and conditions. For the most part, with the exception of independence, we actually can get those from the data. And then there's kind of some more discussions of how we might actually proceed these. We'll come back to that when we kind of think about fitting these things in R. So there's a think, show, tell, and then followed by some intuition about regression inference. And so kind of thinking about what kind of variability we're going to be getting and what it means to kind of have uncertainty in these estimates. So we have aspects of spread that come into this and the standard error of the slope, a formula for that. For the most part, we're going to be letting R do the heavy lifting for those, and we'll be getting output that looks akin to this, finding the standard errors. And so the intercept is less interesting usually, but it also has a distribution that has a t distribution, partly because we're estimating the standard deviation. So for regression inference, that's the topic of section 25.4. We actually think about interpreting these things where we get standard errors, these t ratios later on, and p-values are associated with that. Just checking, this is a great way of kind of confirming your understanding. There's another example about the breakup of ice in a community up in Alaska. A step-by-step example verifying each of those conditions. Very valuable to be looking forward. So one of the things that will be wanting to think about is to look at standard errors for predicted values. And predicted values for mean versus individual predictions, you'll see different approaches for doing this in the predict function in R. And this is described. So here's how we think about confidence intervals for predicted values, and then for individual observations. I like this plot because it actually shows the two different, that you're actually going to get more for an individual than for the predicted value. Logistic regression is a topic near and dear to my heart. It is what we will be doing if we're trying to model moving beyond just two-group comparison of a 0-1 outcome. And so we saw ways of doing that with a single categorical predictor in the previous chapter. This is unfortunately beyond the scope of this course. Some of you may decide to work on projects where you have logistic regression, and I can help you, assist you with your work with that. And this section will be a good starting point, as well as some other resources that I can put together. So all the things we had concerns about regression wisdom still holds. It's just as important later on. There's lots of connections. Some formulas, actually for the most part less important. We'll certainly want you to be calculating test statistics, but other aspects of this are pretty less germane to the big picture. So we have kind of learning objectives for this course, and then ways to actually fit this using R. So we read in the data for the body fat data. We can use the glimpse function to see what's going on with that. We can fit the linear model using LM with y tilde x. The outcome is a function of the x. Calculate the coefficients. M summary gives us a nice terse summary of that. We can pull up things like the R squared value. We can calculate confidence intervals using that object. We can generate predicted plots from that using, we can see that the linearity assumption seems reasonable. We can go ahead and look at the residuals versus predicted values. and also kind of a QQ plot of the residuals. We can use the panel.lmbands function to generate both individual and mean predictions, and then going to go ahead and replicate the analyses from the last example. We also give example here of how you'd actually fit a logistic regression using the same thing except GLM and family equals binomial, but again, that's not part of the core course requirements. That, in a nutshell, is inference for regression.